Alright, we're back. More unit circle mayhem. We are determining trig functions on the unit circle when we know one of the function's values already, but we don't know the others. So we're using one of these, in this case sine, and we're going to find cosine, tangent. Eventually we'll do secant and cosecant as well, but we'll talk about that later. So this is one of the most basic examples. The first method we're going to do is we're going to use the fact that sine squared plus cosine squared equals 1. That's probably the easiest way to do it. And here's how it's going to work. I'm giving you the fact that sine of theta equals 3/5 and that pi over 2 is less than theta is less than pi. What this really means is that the angle is in quadrant. And if you think about where these locate, okay, pi over 2 is 90 degrees, pi is 180, so we are in quadrant 2. That's what that's all about. At no point, I should say right now, at no point should you ever be finding theta in these situations. That's not worth our time. We are just using what we know in order to find the other cosines and sines. We're not doing inverses here because we want exact answers when we do these. Exact answers means no infinite decimals. We're keeping square roots in there and everything like that. So here we go. We need to find cosine and tangent. What we're going to do here, first of all, you always should draw a picture, a little sketch. Doesn't have to be very good, you just have to know what quadrant you're in. Sine is 3/5. That means, remember, the coordinates label as cosine, sine. Cosine is x, sine is y. So if sine is 3/5, it's telling you that the y value is positive. And usually you would have to figure out what the cosine is, and if we're in quadrant 2, cosine is negative. So we have something like that. It's really not that important for this problem because I tell you where the angle is, but sometimes they don't tell you that and you have to use this to figure it out. So we draw a point out in quadrant 2. Doesn't even matter where it's at. Just get it out there. That's all we need. From there, what we're going to do, there's not much more to do there. All we really have to do here is do the Pythagorean theorem here, because what's happening here is we have a triangle, and then remember the x value is cosine, the y value is sine. So cosine, and the hypotenuse is 1. So we're doing sine squared plus cosine squared equals 1. So we already know, so when we write sine squared theta plus cosine squared theta equals 1, we're just going to plug in what we know. We know that the sine is 3/5. So we're going to square that. We don't know what cosine squared theta is, and we're not going to find that out yet. And we're going to get 1. And we're just going to do the math we know how to do. We're going to square that. We're going to get 9 over 25 plus cosine squared theta equals 1. We're going to subtract 9/25 from both sides. We're going to get 1 minus 9 over 25. And you need like terms here. Okay, so we can't leave it as a 1. We're going to change that into 25 over 25. It's a pretty easy switch. That's going to create 1. And when you subtract these, you're going to get cosine squared of theta equals 25 minus 9 is 16 over 25. And when you finish this, you're going to square root both sides. You're going to get cosine theta equals plus or minus the square root of 16 is 4. The square root of 25 is 5. You can do this with decimals. I'm keeping the fractions in there right now. Now you have to determine plus or minus. Well, it's already made the choice for you. Since you are in the left second quadrant, the cosine values will be negative, so you will be choosing the negative from your plus or minus this time. Alright, and that's one of the most important things, because now, I'm going to move my work over here, we can write that the cosine of theta is negative 4 over 5. That's one of our answers. Tangent's a little bit more work. Tangent of theta, if you remember, is sine of theta over cosine theta. And notice we've never found theta at any point in here. We don't need to find that angle. You know the sine is 3 over 5. You know the cosine is negative 4 over 5. You just have to solve a complex fraction here, or simplify a complex fraction, which is just rewrite the numerator, change to multiplication, and take the reciprocal of the denominator, or copy times flip. And doing this math is pretty easy. We get 15 over negative 20, which simplifies down to tangent of theta equaling divide by 5, we get negative 3 over 4. Whoops. Negative 3/4. And that's it. Alright, we're going to do another method, and we're going to spend the rest of the time going through that method. So you can always do Pythagorean theorem. That's one way to do it. This is not very useful when I'm given tangent, because sine squared plus cosine squared doesn't incorporate that. So this is not the best way when I'm given tangent, but I'll show you a good way to do it with tangent. Alright, so say hi to the leopard. Not a cheetah. Alright, so here we go on this one. We have method 2. We're going to use SOHCAHTOA, our old friend SOHCAHTOA, and the Pythagorean theorem on the right triangle. This is the way I prefer to do it. I'm giving you tangent is negative 12 over 5, and we're giving you the quadrant right here. You should realize that that's 270 degrees, and that's 360. So that would be in quadrant 4. So we draw a sketch into quadrant 4. This problem is very important to know what quadrant you're in. We always connect to the x-axis and make a right triangle. Now, tangent is opposite over adjacent. Tangent, opposite over adjacent. The angle is always based off the x-axis. We don't know what it is, but the opposite will be negative 12, and it's negative on the top because we're going downwards here. The adjacent will be right there. It'll be a positive 5. So depending if you're in the first quadrant, they'd both be positive. If you're in the second quadrant, this x value, whatever it would be negative. So that's how you keep track. The hypotenuse is always going to be a positive number. Alright, so now what we do from there, it's pretty simple. We do Pythagorean theorem. 5 squared plus negative 12 squared equals hypotenuse squared. And you're just going to do the math and be careful. You're going to get 25 plus 144. That's going to be 169 equals h squared. Therefore, h square root is going to be plus or minus the square root of 169, which is 13. We're going to take the 13, the positive 13, because we're on the hypotenuse. So that's going to be a 13. All right. Then it's actually really simple. All we're going to do is we're going to say sine of theta. And instead of saying y this time, we're actually just going to do opposite over hypotenuse. The opposite side from here is negative 12. The hypotenuse is 13, and you have your sine of theta. All right. The cosine of theta is going to be adjacent over hypotenuse. So the adjacent side from here is positive 5. The hypotenuse is 13. The biggest area that you can run into trouble here is basically you want to watch out for your negatives. That's that. Much easier, I think, than Pythagorean theorem, but either way will work. Alright, and we're going to do one more here, and then we're going to call it a day. This one's a little bit more funky because what's going to happen is you're going to get some square roots that don't simplify down nicely, so we're going to go over what happens when you run into those. I'm going to fold this up and give a little bit more visual here. You'll see a little bit more color on your paper too. So find the cosine if sine of theta is 8/9 and 0 is less than theta is less than pi over 2. And I want you to find the tangent as well. So quick sketch. This means quadrant 1. Here's 0, here's pi over 2. Always connect to the x-axis. This means the sides of our triangle will all be positive. So sine is opposite 8 over hypotenuse 9. We're going to make use of the Pythagorean theorem here, and we're going to say 8 squared plus x squared, because now we're on a leg that we're missing, equals 9 squared. So you're going to get 64 plus x squared equals 81. Subtraction gives you 81 minus 64 is going to be 17, and we're going to square root that. We're going to take the positive value. Instead of plus or minus, we're going to pick positive because we're on the x-axis on the right, so that's going to be a positive number. If we were over here with the triangle, we'd be taking a negative radical 17. Alright, so that's important. We're going to put it on our triangle, and now we're just going to go ahead and fill in. So we need, and we want an exact answer, so you would not take that 17 and give me a decimal. We're going to leave that alone. So we need to find the cosine first. And we're just going to do adjacent from here, from the center, which is radical 17 over the hypotenuse. That was very simple. Tangent's a little more work. And again, notice on tangent, I'm not really doing sine over cosine here. I'm just saying opposite, which is 8, over adjacent, which is radical 17. And we talked about not having a denominator with a root, so we're going to rationalize that. And all you have to do is pick that denominator and multiply by it again. But you must do it to the top as well. And do the math. This is outside and inside the root, so they're going to stay outside and inside. These are both inside, so it's going to be 17 times 17. So it's a square root of 17 squared, which simplifies down to 17. Last thing you need to do, look at these outside two numbers. They do not simplify. The 17s would simplify, however, this is inside, that's outside, so they stay separate. And that is the tangent of theta right there. And that's it. The big things you have to worry about, depending on what quadrant you're in, remember the hypotenuse is always positive, and whatever quadrant you're in, the x or y could be negative or positive, so you really have to watch out for that. I hope that answers any questions. If you have any more, feel free to leave comments. I can do another video on something else along this topic if it helps. All right, have a good day and good luck.